All right, so what we're going to be learning about with this second lesson is something called the binomial theorem. We do have to just review something that was covered in a probability in another course that you guys took, either Algebra 1 or Geometry. But we have to go over something, I guess it's combinations if you want to think about, but it's this C thing that you see in front of each one right here. Okay, so there's an additional bit of information that you have to calculate besides just what the binomial theorem says, and that C value is associated with this value right here that comes in front, and I'll show you how we can calculate it. So basically, if you are given, let's just say, we'll do it like this. This is the general case. If you have C with n on the left and k on the right, then the way that you calculate this is you have n factorial over k factorial times n minus k factorial. And if you notice, that's this part right here. So if we had actual numbers to work with, so say we had C and then 6 and 1, we would have 6 factorial over 1 factorial over 6 minus 1 factorial, which is 5 factorial. Now, what factorial means, there is a button. If you hit the math button, and then I believe if you move your cursor over to probability, you see the little exclamation point, that is something for factorial. Basically what factorial means is if it's 6 factorial, you have 6 times 5 times 4 times 3 times 2 times 1. 1 factorial would just be 1. 5 factorial would be 5 times 4 times 3 times 2 times 1. And then you look to say, okay, 5 on top, 5 on the bottom, gone. 4 on top, 4 on the bottom, gone. 3, 3, 2, 2, 1, 1, which leaves you with 6 over 1, which is 6. So that would be the value of this combination with 6 on the left and 1 on the right. So you are going to have to do that additional calculation. With the binomial theorem, the nice part is, as you're realizing, you're going to notice a pattern. It's sort of like bookends. The end terms are going to be the same. So once you figure out the first term, that's going to be the value of the last term. And I'll show you what I mean by that. All right, so what the binomial theorem says, you're going to get something that looks like this. So you're going to have two terms being raised to a power. Typically what we would do is we would FOIL the thing out. The only thing is that in order to do that, you sort of want to work with n values that are less or lower, such as 2 would be ideal. But as soon as they get up to 5, 6, 7, it would take way too long to FOIL it and you would run out of time on an assessment. So you don't want to have to be FOILing these out. You want to make sure that you're practicing using the theorem itself. So how the theorem works, n is your exponent right here. So what you're going to find is with this C value that's in front, it's always going to be the value that's on the left-hand side. That's always what you're starting with. The value that's on the right-hand side, you start with 0 and you work your way up. So 0, 1, 2, and all the way up to n. And then the value that comes next to it, A is being raised to the n power. So the n value is the first one you had. B is being raised to the value that's on the right-hand side. Now what has to change is every term after that, the B value you're going to notice is going to be consistent with whatever, the exponent that is going to be consistent with whatever you have on the right-hand side, but you can't keep A to be n the whole entire time. So as the B value exponents increase, the A value exponents need to decrease. So the best way of showing this to you is going with an actual specific example because there's way too many symbols going on here. So let's sort of break it down with the first one. So it says expand 3x minus 2y to the 5th using the binomial theorem. So we have C, 5 on the left, 0 on the right, because that's the exponent we're working with. So now the first term, 3x, is going to be raised to the 5th power. The second term, your negative 2y, is going to be raised to the 0 power. Plus C, 5, and now 1. 3x is now being raised, we're going down to the 4th, whereas the negative 2y is going up to the 1st. Next term, C, 5 and 2. 3x is now being raised to the 3rd. Negative 2y is being raised to the 2nd. Plus C, 5, 3. 3x is being raised to the 2nd. Negative 2y is being raised to the 3rd. Next, C, 5, 4. 3x is being raised to the 3rd. negative 2y is being raised to the fourth. And the last term, which I'm going to add over here, C5, 3x is being raised to the fourth. Or sorry, where am I? 5, 4, 3, 2, this should be 1. That's my bad. This should be to the 0. And negative 2y is being raised to the fifth. So you're going to notice the exponents flip. So we end up with 1, 2, 3, 4, 5, 6 terms. So there's always one more term than the actual exponent that you start with. So we started with it being raised to the fifth power, but we actually have 6 terms. So now what we have to do is we have to simplify. So each of the values in front, each of the C values, what you have to do is you have to use either your calculator or you can write it out long ways. It doesn't matter. So for example, here, let me just drag some more so I have more places to work with here. So let's say, for right now, I'll make separate videos here. We drag this guy down. So if we have C, 5, and 0, well, that's 5 factorial over 0 factorial times 5 minus 0 factorial. Well, 5 factorial is 5, 4, 3, 2, 1. 0 factorial is actually 1. 5 minus 0 is 5, 5, 4, 3, 2, 1. And what you're going to find is that everything cancels, you just get 1. So the first value is 1. 3 to the fifth power is 243, x to the fifth. Negative 2y to the 0 is 1. Plus, second term, C5, 1. So 5 factorial over 1 factorial over 5 minus 1 factorial. 5, 4, 3, 2, 1. Again, you have the calculator that can do this as well. 4, 3, 2, 1. And we end up with 5. So that's plus 5 times 3 to the fourth is 81, x to the fourth. Negative 2y to the first is negative 2y. And we continue the process. So we have C, 5, 2. 5 factorial over 2 factorial. I'm just going to skip. It's 3 factorial. So 5, 4, 3, 2, 1. 2, 1, and then 3, 2, 1 for the 3 factorial. So those guys go away, simplify, and you end up with 10 for this one. So we've got 10 times 27 x to the third times 4y squared plus, now what you're going to realize, again, I told you they were bookends of each other. So if this was 1, then this is 1. If the second term was 5, then the second to last term is 5. And then the middle guys, if this was 10, then this is 10. They have to be sort of a mirror image on both sides. So you don't have to keep calculating. You can certainly check, but you don't need to keep calculating. So we know we have 10. Then we have 9x squared times negative 8y to the third. I'm running out of room here. Plus 5 times 3x times 16y to the fourth. Plus 1 times 1 times negative 32y to the fifth. And then it's a matter of just multiplying everything out. So term number 1 is 243x to the fifth. Minus 5, 81, and negative 2 make negative 810, x to the fourth y. 10, 27, and 4 make 1080. So plus 1080, x to the third, y to the second. 10, 9, and negative 8 make negative 720, x squared, y to the third. 5, 3, and 16 make 240, plus 240, x, y to the fourth. And then we get negative 32, y to the fifth. So this huge thing right here, that is what your final answer is. So you're not going to get a ton of these because, again, they do take a while to answer. But it's definitely, there's a lot of steps, so just make sure you have the calculator for the factorial thing, but realize